What's poppin', dogs? Mr. Allen here with some rewriting of algebraic expressions in standard form. And we're going to be classifying these by degree and number of terms. So let's get after it. First one here, I've got two binomials that are multiplied together. Remember, if there's no operation between them, it's implied that it's going to be multiplication. If there's addition between them, you should be adding them together, all right? Don't make that mistake. If you do the wrong operation, you'll likely get 0 points. That's no bueno, okay? So we're going to go ahead and distribute the 2x to both of these terms, and we'll distribute the 5 to both of these terms. Some often refer to this as FOIL. I'm a fan of just distribution, right? It's a more generic one because that'll work over here as well. But for two binomials, it's first, outer, inner, last. So it's a little acronym to remember that, right? Distribution is all I do, okay? So we got 2x times x. That's going to be 2x squared. 2x times negative 6 is negative 12x, right? We're just multiplying the two numbers together. The x stays the same. When we did the 2x times the x, because it's x to the first times x to the first, you add the exponents, it became x to the second, okay? Just in case you didn't follow that step. Sorry, I, breezed right over it. Then I got 5 times x, which is going to be plus 5x. Nothing really goes together other than they're just multiplied. 5 times negative 6 is negative 30. So there we go. Are we done? No. Got to combine these two like terms in the middle. So then I'm going to have my final 2x squared minus, what's negative 12 plus 5? That's negative 7. The x stays x, right? When I combine my like terms, I'm just adding or subtracting my coefficients, okay? Lovely. Fantastic. That right there is in standard form. I'll even circle it. I'm so happy about that. And then the next thing is classified by degree and number of terms. So our degree is 2, which is quadratic. And then the number of terms, 1, 2, 3. That is going to be, what would we call that? 3 terms? Trinomial. So with 1 term, it's called a monomial. 2 terms I already referred to as a binomial, right? 3 is trinomial, and then beyond that, we just call it a polynomial, okay? Same goes with the degree. We start with constant. That's when there's no variable, right? Like, so negative 6 is just a constant, or negative 30 is just a constant. Then degree of 1 is linear, so I would refer to this as my linear term. Degree of 2 is quadratic. 3 is cubic. 4 is quartic. 5 is quintic. Beyond that, we just call it 6th degree, 7th degree, 8th degree. Ran out of names. I know somebody's like, that's enough. 5's enough, right? Who wants to remember all that anyways? So there we go. Quadratic, trinomial. They might ask you to name it. They might just ask you to fill the blanks. Either way, I think we're pretty good on this one. Actually, one more thing. What's my lead coefficient? It's the coefficient in front of my highest degree term. So 2 is my lead coefficient. Not because of this degree is 2, right? It is the one that's in front of the highest degree term, which just so happens to be 2 as well. Okay. Next one over here. Lettuce. Just had a salad today. Let us distribute. So we got 3x times 2x squared, 3x times 6, and 3x times negative 8. Let me do those first, and then we'll distribute the others. And here's how I like to actually arrange this one. It's maybe a little different than you've seen, but I like it. It helps me stay organized. When I've got 2 of these already in like standard form within the groups, this makes it easy. So 3x times 2x squared is 6x to the third. 3 times 2 is 6. X to the first, x squared. Add the exponents, I get x cubed. Cool. 3x times 6x. 3 times 6 is 18. X to the first is x squared. Then I have 3x times negative 8. That's going to be negative 24x. Okay, now this little organization trick is also going to help me because I'm probably not going to be able to fit everything else that's right there. So I'm going to go to second color here so you see the bottom line. What I'm going to do is as I distribute, I'm going to put that under my like term, okay? So negative 1 times 2x squared is going to be negative 2x squared. I'll throw that beneath the 18x squared, right? Negative 2x squared. Now when I add them together, they're already right there with each other. Then I have negative 1 times 6x. That's negative 6x. I'll throw that beneath the other x. And then negative 1 times 8 is positive 8. So plus 8. And now I can put all of these together. Cool? Lovely. Fantastic. Beautiful. So we've got 6x cubed. Doesn't combine with anything. 18 minus 2 is positive 16. The x squareds stay x squared, right? They don't go away because I was subtracting. We just work with the coefficient. The same goes with addition, okay? Negative 24, negative 6 gives me negative 30x, and then plus 8. So here we have a degree of 3, right, which would be cubic. And then terms, how many terms do we have here? We've got 1, 2, 3, 4. So this is going to be 4 terms, which is a polynomial. Polynomial. Boom. Beautiful. What's my lead coefficient on this one? Well, it's the coefficient of the highest degree term, which is this guy right here, right? So the lead coefficient, if you're asked that, would be 6. Sometimes they'll ask you that when it's in a mess like this, or if it's like, all written out, you have to combine some like terms and rearrange things. They'll ask, what's the lead, lead coefficient? You have to know to look at the highest degree term. Once everything's been combined, that's your lead coefficient, the coefficient in front of that guy right there. All right, that's about it for this one, guys. Hopefully that helps. Just stay organized with your distribution. I like this method here. You don't have to do this. You can put it all in one line, underline your like terms. People like to do that. Someone showed me this one time. They're like, hey, this helps kids. So I adopted that as well in my teaching practice. So hopefully that helps you guys out. All right, have a wonderful day. Stay dope.